Good afternoon. This is Mr. Roberts at Shasta High School. This is the a look at the solutions to the Honor Study Team test for Chapter 2. This is being recorded on the 26th of September 2016. And let's start with the first question. So the first question had, I think, 4 parts to it: A, B, C, and D. And the questions was read each information about several lines below. If there is enough information, circle enough info. Meaning, if there's enough information to come up with the equation that line, circle that. If there's not enough information, tell what additional information you would need to find a rule or equation. So when we look at A, we're told that this line has a slope of -2 and a y-intercept of 4. So let's make this a little bit larger. Here we go. And we've got a y-intercept, it says, that is located at +4. So here's our y-intercept. And we have this slope pattern of -2, so it's down 2 over 1, down 2 over 1. Oh, look, there's an x-intercept, down 2 over 1. So I could continue this pattern out to the edge of my paper, and probably at this point I should grab a line tool and draw the line that goes through those points. And you can say here's the line y equals -2x plus 4. Well, there's clearly enough information there to determine a unique line, both the slope and the y-intercept. So I would say that there is enough information, and the equation of that line is y is equal to -2x, and then starting at 4. So let's go down to part B. Part B says, line B passes through the point 2, 2. So let's go ahead and graph that. It's passing through this point right here, 2, 2. Right? That's all it tells me. Right? The problem with that is there are multiple lines that pass through this point 2, 2. Right? For example, this line or this line, or that's an attempted line, right? But I think you know what lines look like that would pass through there. So this definitely it eliminates some things that don't go through that point at all. So I do know where it's going through, but it's not enough to come up with a unique line, right? There just isn't enough information there. What could make this doable is if I was given, so for example, I could be given an additional point. Or I could be given maybe the slope pattern. That would be enough. Or maybe a y-intercept. And actually, I could be given an x-intercept for that matter, right? Both of these are just, if you think about it, they're just additional points as well. So not enough information. I need to have either one point in a slope pattern or the equivalent of 2 different points to come up with the equation of a line. So let's move on to part C. Part C says that it goes through the origin, okay, and it has a slope of -7. So we're beginning here, and then I'm going up 7 over 1. And I could also go down 7 and back 1. So that would definitely form my line. So that's probably a pretty good look at what this function looks like, and definitely this is enough information because I'm told it's going through this one particular point and I'm given the slope. It's constrained to just this one unique line. So the equation of this I could write as y equals it has a slope of -7. I totally didn't catch that symbol, right? I got to be careful because it turns out what I've done is a line with a slope of +7. So if it's -7, I need to go down 7 and over a unit, and I could go from there up 7 and back 1. And you see how that happens. It just sneaks up on you. You think everything's fine, and then a mistake. That is much better. And the equation of that line is y equals -7x. And you could put the +0 if you want, or just leave it off, because if it's not there, it's implied that the y-intercept is 0. It's going through the origin. And then finally, we're given 2 points. Oh, by the way, that is enough information. And given 2 points, I'm confident that that is enough information right off the bat. The 2 points that were given here were at -2, -1, so I'm going back 2 and down 1. And the other point was over at up over 1 and then up 5. So these are my 2 points. Let's draw the line that goes through those. And when we look at this line, it certainly appears that the y-intercept, right, is the y-intercept appears to be at the point 0, 3, right? It's happening when y is 3. But we should be careful because it could be very close. It could be, 15 sixteenths. I'm not exactly sure. So I want to caution you to just because it looks like it's going through there, don't assume that it is. Especially for the honors class, I could give you a question where I want to see, hey, are you questioning the validity of that graph, because it could do something else. If I take a look at this and figure out what the slope is. The slope, I've got the change in my y value, and if I'm looking, here's my two different y values, and I could certainly say 5 minus -1. So my change in y would be positive 6, and the change in my x values, you can see x's are 1 and 2. I could certainly write 1 minus -2 and get 3. So my slope is that change in y divided by the change in x. So I have a slope pattern of up 2 over 1. And I just want to confirm, is the y-intercept really 3? So it's pretty easy to do. I'm just going to pick one of my 2 points. I'm going to pick this point. I've got an x value and a y value, and I'm going to plug those into y equals mx plus b. My assumption is that it's a line, and y is 5, and that's going to equal 2 times my x value of 1 plus b. And you can see, yeah, I'm taking away 2 from each side, so I get that b really is 3. So now I've confirmed what I see graphically. It appears my y-intercept is 3, and it certainly is algebraically. So the equation of this line is y equals 2x and then plus the number 3.